Hi, my name is Lori, and I'm a support engineer with Geoslide. I've created a series of getting started tutorials for new users to GeoStudio. So if you're brand new to using the GeoStudio software and you're not quite sure where to start, then you've come to the right place. These tutorial videos have been designed to help walk you through the basic steps of creating a simple model using GeoStudio. The main topics that will be covered in this series will be how to use define to set up a numerical model, using the solve module to compute the numerical solution, and how to use contour to view the results and to gain a deeper understanding of the problem you're modeling. You can pause, stop, fast forward, or rewind these videos at any time by using the controller bar positioned at the bottom of the window. If English is not your first language, you might find it helpful to print out a copy of my script, which is available as a PDF from our website. So let's get started. ctran W is always used in conjunction with seepw or Vados W, finite element programs that are part of the GeoStudio product line. The first step is to model the flow regime. To start this lesson, we're going to conduct two contaminant transport simulations for the following profile. On the upland is a pit containing a contaminant fluid with a relative concentration of 10 kilograms per cubic meter. To the right of the pit is a valley where the water table is located at the valley floor. The first ctran W analysis will be a particle tracking simulation, which is a quick way to determine the extent of the contaminated region by simulating how individual particles would move through the soil profile with time. The second simulation will be an advection dispersion analysis, which will model the concentration of the contaminant plume as it advances through the profile with time. Chemical diffusion is considered inconsequential and is ignored in this particular analysis. It's assumed for this tutorial that you are already familiar with the GeoStudio environment. If you've never worked with GeoStudio before, you may wish to first review the Getting Started tutorial for seepw. One of the powerful features that is new to GeoStudio 2007 is the ability to run many different analyses within the same project file. The geometry is considered project-specific, but you can change boundary conditions, material properties, and even different types of analyses. For this ctran W Getting Started tutorial, we're going to add the two ctran analyses to a seepage analysis that has already been created and solved. To add a ctran W analysis, go into Key in Analyses. We're going to add each analysis one at a time. The first analysis will be the forward particle tracking analysis. ctran W will use the existing seepw results. So this means the seepw analysis is the parent of the ctran W analysis. There is a time component to the particle tracking analysis. The time that we're going to model is approximately 7.5 years, or 2,750 days. Let's analyze 55 time steps with 50-day increments, which results in a total elapsed time of 2,750 days. Since we used hydraulic conductivity values of meter per day for the seepw analysis, the time steps for ctran W must also be in days. The geometry is common to all analyses in the project file, but materials are analysis specific. To define the contaminant transport properties for the soil, we need to go under Key in Materials. The silt material has already been created since it exists for the seepw analysis. But we need to define the longitudinal and transverse dispersivity values. These values will be ignored for the particle tracking analysis, but will be used for the advection dispersion analysis that we'll do next. Now all we need to do is place the particles on the profile at the bottom of the contaminant pit. First, let's turn on the background grid to 0.25 and zoom into the area of the pit. Now choose Particles from the Draw menu. Use the cursor to place the particles on the profile. The blue circles indicate the starting positions of the contaminant particles. Now the particle tracking analysis can be solved. ctran W will track the particles through the finite element mesh using the CW computed velocities and water contents. Notice at the end of the solve process, the solve window summarizes how many particles have moved outside the mesh. To view the results, click on the contour icon. The results that appear by default are the location of the particles for the last time step. In this case, the last time step corresponds to an elapsed time of 2,750 days, or about 7.5 years. To view results for any other time step, you can use the time steps window on the toolbar and use your up and down arrows to move between the results. You can also click on the results directly. To shade between specific particle migration paths, choose Particle Shading from the Draw menu. Use the cursor to select the paths you would like to be shaded between. Result information about a specific particle can be viewed by choosing View Particle Information and clicking on the particle directly. Now let's look at how to conduct an advection dispersion analysis. While particle tracking is a quick way of presenting the contaminated region, a complete advection dispersion analysis is required if you want to know the concentration within the contaminated region. Use key-in analyses to create the new analysis. This time, we're going to create a clone analysis. Cloning analyses is a very helpful feature when you want more information than just the geometry to be shared between the two analyses. In this case, we want the material properties to also remain the same. The CW analysis is still the parent of the advection dispersion analysis, which makes the two ctran W analyses siblings. You can see that the material we defined, which already has the longitudinal and transverse dispersivity values, is still applied to the geometry region. Boundary conditions are first created and then assigned to the geometry using Draw Boundary Conditions. In this example, a continuous injection of contaminant is assumed to exist along the bottom of the pit, and the relative concentration along these nodes will be set to 10. The nodes that exist on the valley floor will be defined as a free exit boundary, which allows both dispersive and advective fluxes to cross. Now let's solve the advection dispersion analysis. Open Contour. Concentrations can be labeled using the Draw Labels command. The View Result Information command allows you to check the exact computed values at any node. You can hold down the Control key to multi-select nodes. You can view the amount of mass that has accumulated at elements. Select Mass Accumulation from the View menu. If no elements have been selected, the box will show the total mass in the system. Another powerful feature of Contour is the ability to generate graphs of the computed results. Let's look at a graph of the computed concentration along a vertical section. Choose Graph from the Draw menu. Add a graph, name it, and select the parameters that you want to graph. Click on step 55. Highlight a group of nodes, and once they've been selected, a graph of the concentration versus y-coordinate for these nodes will appear. Now let's make a clone of this graph, but this time select all the time steps. Another way to view the results is to contour one concentration value at different elapsed times. For example, the location of a relative concentration of 1 for each time step. These special contours are called isolines. Type 1 in the Value to Contour edit box and select all the time steps. To display the time increments on the contour lines, choose Draw Contour Labels and click on the contour line. New to GeoStudio 2007 is a reporting feature. If you need to generate a report of your input, select Report from the View menu. Once you save the report file, your default word processing program will open with a generated report. You can now insert pictures, apply style templates, or add and delete data. If at any time you need help understanding a dialog box, you can click on the question mark in the top left corner to access the online help, or use F1 on your keyboard. You can also switch to the Analysis Start page, which has PDF copies of all the engineering books for GeoStudio under the Documentation section. These books are very helpful in describing the features in the software and the theory behind them. You can also search through the examples database using specific keywords. When you're done, you can return to your analysis by clicking on the analysis list. We've reached the end of this introductory lesson. Not all of the powerful features of ctran W have been used or discussed during the lesson. Specific details about each command are given in the online help and in the supporting documentation for ctran W. Thanks for watching.